The Jinan Plain is fertile and serves as Taiwan's largest granary. Although the Wushantu Reservoir and the Jinan Canal were constructed during the Japanese colonial period, their irrigation capacity was still insufficient. Thus, the government began the construction of the Zengwen Reservoir. This largest reservoir in Taiwan, with multiple functions such as water collection, irrigation, power generation, and flood control, is the first major water conservancy project undertaken by the Taiwanese themselves since the government's relocation to Taiwan, following the Ximen Reservoir. It was designed and supervised by the Ministry of Economic Affairs and Sinotech Engineering Consultants, with the Retser Engineering Agency solely responsible for its construction. It laid a solid foundation for future public works in Taiwan. Zengwen Reservoir is located on the upper reaches of the Zengwen River, about 65 kilometers northeast of Tainan City. With a storage area of 481 square kilometers and a capacity of 700 million cubic meters, it was the largest earth-fill dam in the Far East at the time. The project included a diversion tunnel, dam, spillway, underground power station, and cofferdam. The RSEA, established by the Veterans Affairs Council, had completed various projects before this, such as the Central Cross Island Highway, the Northern Cross Island Highway, mountain roads across Taiwan, Pingdong Airport, and the Ximen Canal, becoming a public organization with rich personnel organization management and on-site construction experience. In 1965, after the completion of the Ximen Reservoir, the RSEA acquired the leftover machinery and equipment. In 1967, it purchased machinery from the American firm Van Nel in Taiwan, boosting confidence in undertaking the Zengwen Reservoir Project. By that time, the agency had over 4,200 engineering technicians and more than 1,100 major construction machines, fulfilling the conditions for undertaking large-scale projects. When the government began planning the construction of the Zengwen Reservoir, most politicians and public representatives leaned towards international competitive bidding, doubting the capability of Taiwanese to independently undertake such a massive and complex project. However, the director Yen of the RSEA strongly disagreed, believing in the agency's capability to complete this significant project. He argued that if the country's major constructions always depended on foreigners, it would not benefit the nation. Therefore, the agency's undertaking of the Zengwen Reservoir Project marked a new and breakthrough beginning for the nation's engineering industry. Finally, the government made a principled decision to entrust the project to the RSEA, which knew failure was not an option for the Zengwen Reservoir Project. Therefore, it coordinated with professionals from Taiwan Power Company, the Water Resources Bureau, Ximen Reservoir, and other units to join the RSEA system, recruited a large number of specialized university graduates, and selected young and strong veterans to train as heavy machinery operators, numbering over 800. It also enlisted Japanese and American consultants to complete all preparatory work. In July 1967, the government decided to entrust the entire project to the RSEA, with the diversion tunnel project needing to start immediately by the end of October. Within a short 3 months, the agency made every effort to complete the initial mobilization work and successfully prepared on schedule. To prepare for the office and accommodation needs of the engineering staff, more than 10,000 square meters of construction housing and warehouses were built in Yanshuku, near the work area. The engineering staff began to carry out the planning work for various projects. First, it was necessary to build construction roads from Nanshi to the dam site, a total length of 13 kilometers, including 4 bridges and 58 box culverts. These preparatory works were completed in coordination with the start of the diversion tunnel. Constructing the spillway and the underground power station required a significant amount of concrete. To cope with the concrete work of over 500,000 cubic meters for the entire project, the RSEA installed a stone crushing plant capable of producing more than 200 tons of concrete aggregate per hour. The sand and gravel produced by the crushing plant were transported to the nearby ready-mix plant via conveyor belts, mixed into concrete, and then transported to the construction site by mixer trucks. Every step was automated, overcoming the difficulties of rapid mobilization. The diversion tunnel project officially broke ground on October 31, 1967. Before the construction of the dam could begin, it was necessary to divert the original stream, so a diversion tunnel and a cofferdam were built upstream, allowing the main dam to be constructed on a dry riverbed and safely constructed without the threat of floods. The diversion tunnel project was the first major project of the Zengwen Reservoir, including 2 tunnels with an inner diameter of 12 meters. Tunnel number 1 is 1,240 meters long, and tunnel number 2 is 1,083 meters long, requiring the excavation of approximately 420,000 cubic meters of rock and the placement of about 110,000 cubic meters of concrete lining. The tunnels were constructed using the half-section advanced tunneling method. For this project, the RSEA specially introduced the most advanced engineering machinery of the time and adopted the new Austrian tunneling method, using steel supports and steel formwork for concrete lining. There were 2 sets of steel molds for casting the lining concrete, which could advance automatically, a first in domestic use. Concrete pumps were used for casting, and it was only through precise construction planning and innovative construction equipment that this important work proceeded very smoothly. After the early levee was closed, the water flow of the Zengwen River was diverted into the tunnel. This diversion tunnel started construction on October 31, 1967, and was completed on November 12, 1969. After 742 days of hard work and dedication, the first task was accomplished. The next goal was the cofferdam. The filling of the cofferdam began on October 25, 1969, and was scheduled to be completed by May 31, 1970. The cofferdam is actually part of the dam, and its construction method was completely the same as that of the dam. Building the cofferdam was essentially a rehearsal for the construction of the dam. The cofferdam was 60 meters high with a volume of more than 1.37 million cubic meters. It was divided into 3 zones: an impermeable clay core, a semi-permeable gravel body, and a cobblestone shell, with layered filling and compaction. To undertake this project, the RSEA introduced large machinery never seen before in Taiwan, such as 35-ton dump trucks and automatic double-wheeled spiky rollers. The performance of these heavy machines was excellent, demonstrating high work efficiency. And after the project, these heavy machines also made significant contributions to Taiwan's subsequent major national constructions. On May 20, 1970, thanks to the relentless efforts of the engineering team, the cofferdam was completed more than 10 days ahead of schedule, in just over 5 months, reaching the designated height and successfully withstanding the test of floods brought by Typhoon Iris, with water flow exceeding 3,000 cubic meters per second. On June 7 of the same year, Chen Taching, the chairman of the provincial government, and Chao Chu-yu, the chairperson, presided over the completion of the diversion tunnel and the cofferdam, as well as the groundbreaking ceremony for the dam. The dam of Zengwen Reservoir is a typical center impermeable core rolled earth fill dam and is the first project in Taiwan to use large-scale earth-moving machinery. The first step in the construction was to clean the dam foundation, ensuring a tight and good contact between the new fill and the old foundation. At the top center of the dam down to the foundation, there are 2 curtain grouting belts reaching down to 70 meters deep, which prevent the water stored in the reservoir from leaking out. The excavation of the spillway and the dam construction progressed simultaneously, with the goal of stabilizing the slopes to prevent landslides. This task involved the excavation of more than 6.2 million cubic meters of earth and rock, employing step-by-step excavation methods. On October 31, 1970, all foundation treatment work for the dam was completed, and construction workers laid the foundation for the dam, marking the beginning of the dam's fill construction. From a cross-sectional view, the dam's cross-section is divided into many areas, each with materials from different sources. The most important part of an earth-fill dam is the core, which consists of very fine soil that slows water permeation and acts as a barrier. The fill for the dam was sourced from the river terraces upstream of the dam site, utilizing a large amount of heavy machinery, dump trucks, rollers, sprinklers, layer by layer. The excavated earth and rock from the spillway also served as a source of materials for the dam, which, according to the design specifications, had to be crushed and screened, sorted by particle size for storage. The RSEA set up 2 dam material processing sites, where the earth and rock were screened, crushed, and moistened to the required water content before being transported to the dam site. With the spirit of moving mountains, the construction staff used truckloads of earth and rock to layer the dam, filling it with a vast amount of earth and rock. Considering an average load capacity of 15 cubic meters per dump truck, it took more than 600,000 truckloads. From the foundation laying in October 1970 to the completion in 1973, there were only over 600 working days, averaging about 1,000 truckloads per day, which means transporting 15,000 cubic meters of earth daily, an astonishing amount. Working day and night, the construction team even set a record of 30,000 cubic meters of fill in a single day. The dam was built layer by layer, with watering, plowing, leveling, and compacting each layer. Supervisors constantly tested the density, and the dam area was equipped with 46 sets of seepage meters, 4 sets of seismometers, and 27 displacement control points to monitor the dam's stability during and after construction. The dam's elevation is 235 meters, with an actual height of 133 meters from the riverbed rock base, approximately 887 layers at 15 centimeters per layer, nearly reaching 1,000 layers. The concrete pouring for the spillway began in June 1971 from the bucket section and was completed in June 1973. The pouring sequence was carried out in blocks and layers, divided into the bucket, discharge channel, overflow weir, 2 piers, and abutments. The spillway's structural concrete, for convenience and cost-saving in construction, used trucks to transport concrete buckets to the construction site, where the buckets were hoisted to the pouring molds to expedite the construction process. The reservoir's 5th project is the underground power station and several tunnels leading to the power station, including the access tunnel for transportation, 392 meters long, the water diversion tunnel for leading water to the generators, the tailrace tunnel for discharging the used water, each about 100 meters long, as well as the surge shaft, ventilation tunnel, valve chamber, etc. The underground power station is a domed cylinder. The arched top was constructed first by building a circular beam, progressing upwards to form the dome and excavating downwards for the cylinder walls, standing 32 meters high from the foundation to the top, with a diameter of 26 meters, divided into 4 levels to eventually house a 50,000 kilowatt hydroelectric generator. Due to the urgent timeline, the Zengwen Reservoir Project was conducted in 2 shifts, day and night. Under the illumination of giant floodlights, all works, including excavation, filling, and concrete pouring, proceeded at full speed in every workshop. To undertake this enormous project, the RSEA invested heavily in advanced engineering machinery, with nearly 500 main construction machines and a total of over 1,900 including auxiliary equipment. In this remote work area, a maintenance shop was set up capable of handling any repair work. The Zengwen Reservoir was a leading national project, independently contracted by the RSEA under a contract system, requiring substantial investment. It aimed to provide continued service by retired military personnel, contributing to major national construction projects, while honing the skills and experience of the workforce in this high-standard project, cultivating a strong engineering and construction human resource for the nation. Under this long-term goal, the RSEA bravely faced all difficulties during and after construction, undertaking this arduous task. As the construction of the reservoir approached its final stages, the dam's filling reached an elevation of 215 meters, only 20 meters below the dam top. The spillway's discharge channel was nearing completion, and structural concrete began construction on the saddle and piers. This part mainly consisted of one rolling dam, 3 gates, 2 middle seats, and the side abutment and guide walls. To secure the gates, a BBRV pre-stressed construction method was used for the anchorages. A steel frame was used to fix the position of 20 sets of pre-stressed steel wires, with all anchorages deeply embedded in the concrete structure. A 300-ton hydraulic press applied pre-stress to the steel wires, which would later support and secure the gates. All structural concrete of the spillway used steel molds, which were raised, assembled, and pieced together using cranes, saving unimaginable amounts of scaffolding work. A bridge built with a steel frame spans over the spillway at the top of the gates, connecting roads for access to various places. Each major project gradually reached its completion. During the dam filling process, the construction paths used for transporting fill materials were also backfilled, smoothing the dam's slope. On April 8, 1973, the dam filling reached its final stage, and a topping out ceremony was held at the site. The main tool for the filling, 35-ton trucks, lined up, and upon command, the filling materials were released, marking the completion of the last fill and the dam's completion. The then Premier Jiang personally visited, offering his regards to the construction staff and RSEA employees. April 28 is a day worth commemorating. On this day, the preparations for closing the diversion tunnel were completed, and the gates were closed to begin water storage. This event occurred 6 months ahead of the scheduled completion date, allowing the reservoir to start functioning and providing benefits a year earlier than planned. The water level gradually rose, slowly gathering, submerging the grass and trees on the surface. By June 3, the water level reached an elevation of 154 meters, with a depth of nearly 50 meters, sufficient for power generation. The tailwater from power generation was directed to the downstream Wushantu Reservoir, providing immediate irrigation to the long-drought Jianan Plain. Since 1966, the RSEA mobilized and invested heavily in construction machinery, with 3,500 RSEA employees, meeting expectations and completing this challenging project on time and with quality. The successful completion of the Zengwen Reservoir marked a milestone for the RSEA, transitioning from a phase of small-scale construction mainly relying on machinery and manual labor to independently undertaking large-scale projects. For Taiwan's construction industry, it proved that major national constructions could be self-built without relying on foreign assistance. The thousands of engineering personnel trained during this project became the backbone for subsequent national projects, including the 10 major construction projects and the 12 and 14 construction projects, earning the RSEA the title of Taiwan's construction industry aircraft carrier. This enabled us to leverage domestic construction experience to expand business overseas, exporting our technology, glory, and friendship to other countries.